right, we'll go ahead and kick this off. Everyone, this is 30 Minutes with a Hacker Call. We've got Brett Scott and Josh Harp on the line here, who are both hackers that are in the trenches every day doing this, doing projects with our government, and also running the Arizona Cyber Warfare Range. So this call and talking with Brett and Josh, we thought would be good to, if you could mute out your phones if you're not speaking, that would be helpful. But this call is going to be talking about phishing campaigns. It is one of probably the biggest way hackers are getting in to companies, and so I wanted to turn it over to Brett to kind of talk about why he felt this would be the best focus for this call. It was really his suggestion that we do this. And Brett, I'll let you tee it up however you want to.
Yeah, I greatly appreciate that. So somebody's in a big room, so if you're in a big room, if you can mute that, is super duper. Thank you. So my name is Brett Scott, and I'm Director of Security or Solutions Development here at Tech Data. And I work very closely with Josh and Ruben and the team, Marshall, Sandeep, etc. Our folks that deliver services, and of course, one of those services is red teaming and hacking. So this thing that we're going to demonstrate for you today, 85% of all breaches happen just like the ones that we're about to show you. So of all the companies that are there and out there, there's a very, very good chance this is immediately relevant to you and something that is likely to happen to you again. So this is a really important starting point to discuss what is essentially the greatest threat to your organization. And then Joshua Harp is going to be leading this with the hands-on demonstration. And so I'm going to turn it over to Josh so he can talk to you about some of the parts, and then I'll just try and be here there to help him out.
And just once again, please mute out if you are not Brett or Josh. Yeah, everyone, please mute your phone. Thank you. All right, Josh, go ahead. Appreciate it.
Awesome. Thanks, guys. So, as Brett mentioned, 85% of the ways an adversary outside of your organization is going to get in is through social engineering. And social engineering can take on many forms. You have your standard phishing, which is going to be an email-based attack. You have your phishing, just as it sounds, it's phishing, but with a V as in Victor. And that's usually over voice. So someone calling into the help desk, impersonating an employee that works for your organization, or someone calling an employee that works for your organization, impersonating themselves as an administrator or manager or someone who has some credentials to demand things of them and actions that they need to do. You have physical forms of social engineering. One of the primary ways penetration testers attempt to gain physical access to an organization if they don't have it would be through tailgating. So following people into their organization's building, bypassing physical controls, to then, drop USBs or whatever it might be within your office spaces. So for this call,
I'm in this computer. What do I do?
For this call and for the measures here, one of the things we're going to be doing is primarily just showing you phishing and what phishing looks like. So there are a lot of steps along the way that an attacker or an adversary might use. Everyone's tactics, techniques, and procedures could differ. A lot of what we've started to see recently in terms of how attackers are attempting to get in through phishing is by what we call either typo squatting domains or an IDN homograph attack. So typo squatting, just as it sounds, is usually only effective when you're trying to get a user to come to your site by mistyping their own domain. So you may exclude an A or you may include an S, which is close to an A on the keyboard. And then when someone goes to that domain now, you have some client-side code that executes and attempts to infiltrate their system through the browser. Now, Typo squatting can also be leveraged when trying to send out your phishing emails to look as though you actually are within the organization. This could play on individuals who may be dyslexic, um, or this could also just play on people who don't necessarily check the originating user's um, email address and just say, oh yeah, that says, an example of our organization, IC Tech, and DAT in the first word, you don't necessarily see the A. Okay, this could be from a tech data employee, especially if the first portion of the naming scheme shows, as we use, our first names and then last names at techdata.com. So for our engagements, we leverage some forms of typo squatting, specifically when it comes to watering hole based attacks. And so watering holes would be when we're sending or directing a user through an email, like with a click here or follow to this domain name. Those are going to be the cases which we may use those typo squatting functions or features of a domain, and that's just because when it's in the browser, as you can see the domain name right here, you may not necessarily see an I missing, right? Especially when everyone in social engineering or security awareness training is taught to look for this lock and look for, HTTPS, it's a secured site. However, as I'll show you later, just going based upon this and a lock is not necessarily the best. And the reason for that is because you have ways to now receive what is called certificates, and that's the reason why you have the HTTPS in front here, freely and easily accessible. So primary way and something that's been going on for a long while now, at least the last 3 years, is what's going to be called IDN homograph attacks. And so IDN stands for an international domain name. And so what this would mean is, and there's what's parallel to that is called Punycode. Punycode, and I'll show you a Punycoder here. Punycode is effectively this text. And so this text is what's translating and converting a limited non-written characters in ASCII to ASCII encoding. So as you can see on the text example to the left, that is effectively what our organization's domain name looks like. And to the naked eye, there's no way to determine that this domain name is not legitimate to the one we actually use within our organization. The only way to know is if we actually translated it into its raw Punycode format. Now, there are methods in place, specifically within some browsers like Chrome. Firefox has started to do this. Some versions of Edge, which is a Microsoft browser, I believe, do it. But there's many browsers out there that don't by default translate a Punycode domain into its raw format. So if you were to, and mail clients for that factor, I know that some of the mail clients have phished again don't actually by default change this domain into its Punycode format. So if I was to send you an email using an IDN, you'd say, oh yeah, that's coming from within my organization, and you may become victim and susceptible to it. So to mention what this is and why it's similar, I just simply used a letter within Cyrillic. There are letters within Turkish, there are letters within Greek, there are letters within some of the South American languages that their characters mean something within its own language. So Cyrillic is Russian. And so this character means something within the Cyrillic language, but to us, the attacker, this also looks like a character within the English alphabet, which is used within a lot of organizations now. So yeah, so international domain name homograph attacks, it's very common. there are ways to mitigate the attack and how it works. But again, if within your standard mail client you see that something is coming from your organization, you're not necessarily going to take the measures to look for and validate that it's coming from outside or coming from a domain that's not controlled by you. So that's going to.
Yeah, to reinforce that point, to the user, all the training in the world, you could say, don't click on phishing, verify the domain, do all these things, pay attention. To the average human being, they would look at something and it would say to them, oh, this is techdata.com. In fact, it's a different domain. And therefore, the user is being defeated because the technology exceeds their ability to discern the deception. So that's why homeographic domains and puny and all those things are so successful as attacks, because regardless of how well trained your people are, they are probably not going to catch these types of attacks.
Yeah. So this is also very and primarily effective against mobile users, so users who access their mail on their mobile phones. Reason for that is sometimes the mobile browser doesn't do the translation for the puny code. I think the last report I had seen was that only on mobile devices the Chrome browser was doing this, and now with iPhones and on some Androids, people don't necessarily like to use Chrome. They may use Firefox, or in the case of iOS devices, they're going to use Safari. But yeah, even I have seen as well in doing this form of phishing or using these IDN international domain names, users, even if they do see the raw puny code, they just interpret it as machine language or something that has happened within their browser, and they'll not pay any attention to the fact that this is illegitimate. Again, that can go into, as Brett mentioned moments ago,
So
how
it's
effective security awareness training is.
if it was legitimate, would it show up? What would it show up in the puny code? Just, I'm trying to understand this.
So,
what it
like if it was a standard techdata.com like this.
Yeah, correct. Techdata.com. Correct.
It's not gonna show anything in puny code, and the reason for that is because you're not using a international domain name character. So in this URL, that A is the international character. The other A is a standard ASCII A. The rest of the letters are standard ASCII. It's only that character that's different.
Gotcha.
So again, just to cycle that back again, it would look just like tech data. What makes the tech data look differently on the top example is the fact that there's a Cyrillic character that's been included. But if it's just techdata.com, it would just be techdata.com.
Makes sense.
So that is a pre-investigative measure that is used by adversaries. There are many tools that will automate this task in finding typo squatted domains and finding homograph-based domains, and easily tell you whether or not they've been registered. And then, it's a matter of, does someone have $12 or $8 to register a .com domain? And because there are who-is protections for that in different places, you can host a VPS, right? This makes attribution difficult for ultimately who is trying to attack us. So
awesome. Yeah, I was just going to say, let's move on to how an attacker formulates and executes a phishing attack using one of these domains against a company.
So one of the things I'd like to use first is how harvesting occurs, if that's okay.
Perfect.
Okay, so in a lot of social engineering engagements from a simulated attack, meaning you purchase a service through us and we do it, we have options of whether we do what's called open source intelligence gathering, meaning finding out employee email addresses through different iterations of scraping different websites through automated tools or through manual mapping. or we have options where you can just simply provide us an Excel spreadsheet with the list of employees you want to include in the engagement, and then we can group them up and send them different templates. I'll show you an example of a template later. So this tool that I have up right now is an open source tool that anyone could pull down from GitHub and use on the day-to-day for their engagements. We incorporate many different open source tools along with proprietary tools for scraping. It's best that I show you the open source because that's not necessarily secret sauce. So the email harvester, the way that this works is, as you can see within my syntax here, I'm simply selecting the Python script to run. I'm giving a distinguisher of the domain that I want to use, and I'm saying use all resources of search engines. So search engines from Baidu, which is a Chinese-based search engine, to Bing, which is run by Microsoft, to Google, and so on. Within the Python script, there are special methods or operators that they use to determine to include search Instagram for this domain, search LinkedIn for this domain, search YouTube, use Google Plus, Ask, and so on and so forth. Sorry, excuse me. Dogpile is not also another search engine that's also used. Most people are only familiar with the standard Google or Yahoo. I guess no one Yahoo's it anymore. But most people, when they're doing search engines, it's just Google. But all of these aggregate data in different ways. So I ran this against our own domain, and as you can see, it pulled up multiple email addresses which are potentially used within our organization. Now, because this is a recorded call, I'm not going to say necessarily which ones are accurate and which ones are false positives, because these tools are prone to false positives. So it may say, hey, this is a domain, but when you go to validate and check what not domain, email address, when you go to validate and check that it is a valid email address, it may return that it's not. And that's just because of the way the programmer has done their parsing and their checks on the back end. But there are some email addresses within here that are accurate to our organization.
Josh, my headset. I would think there would be a lot more than this. So this is going out to the internet and it's pulling all these emails, but there's relatively not that many right there. So can you explain the discrepancy?
So the discrepancy is why there might not be so many is because when someone is registering a LinkedIn page, they may not use LinkedIn as their company email address as their LinkedIn login. There may be within the LinkedIn site or their LinkedIn profile their specific email address. And so when these are harvesting or going out and scraping, dependent upon the way that the individual who's programmed this has determined the harvest to occur, it may not check for those types of variables within the profile. This could be just going out and saying, hey, check all recent pastes or breaches, right? And let's see if there have been a leak of the information. But I wouldn't necessarily focus on how many email addresses you obtain, because it ultimately only takes for one individual within an organization to ultimately respond to a phishing email that leads to the breach or the compromisation. So if we went through here and parsed, there's about 5 or 10 email addresses that we could go based off of for people within the organization to say, okay, and I'm not going to leave that up on screen just because I don't want to have to deal with that later. That you could say, okay, there's 10 people that I'm going to work to either do spear phishing against. So now that I have their first and last name, I'm going to map out their LinkedIn profile. I'm going to get to know this user, and I'm going to formulate an email that isn't generic and is more pinpointed to them and is likely to result in them successfully clicking on the link.
Most importantly, this is only one tool using one technique. So there are many, many different ways to get this done. But we are to 5 minutes left in this call, so I'd say let's move this thing along.
Okay. So just then, finally moving forward, this is an example of a social engineering template that might be used. This is just hey, we're help desk and we're letting you know that your credentials are about to expire, and if you don't log in within the next 24 hours, or if you fail to take action, you're gonna be locked out. So the best way to do this is, use the following link to log in. So the following link is what will be used to send the user to a harvesting site. And let me pull up the harvesting site for you guys here. This is what a harvesting site might look like. So obviously this domain that's being used, controlled by us. If you're not, savvy enough to look and make sure that, it's .com or whatever it might be, you may be susceptible to clicking on this, because the way most people are trained is to check to see if there's an HTTPS and a lock, and it ultimately looks like it's a legitimate site. So now, if a user was to input their credentials in here on my server on the back end, I have ways to now harvest and say, okay, that's the user's email address and that's their password. With that, you might say, well, couldn't they enable two-factor authentication to mitigate someone who's just grabbed their user ID and their password? Well, within the proxy server that is proxying this connection to a legitimate resource and pulling down its actual configuration, I would say, well, I can also intercept that cookie, because that's all two-factor authentication is it's a method through cookies to validate it's a user. So in capturing that cookie, I can do cookie edits within my browser to then validate myself as you, even though you have two-factor. That's getting a little deep into the weeds, but that would be a way, even though you have that as a means to mitigate, it can also be used against you if someone has the appropriate resources in place.
So you're in the middle. With this website, we're in the middle of all of those communications. The authentication could actually go through to your actual domain. The only problem is it's coming through us in the middle, and as a direct result of that, we get all the stuff that we need, including the credential and the active login. So if you don't catch it up front, then you're passing through something that allows intercept to occur, and that's how that works.
So here you can see some, the fishlets that's being used. A fishlet is just the way the tool is set up. So I can write custom fishlets per whether you're using OWA or another authentication measure, or if I'm trying to get past an authentication portal. You see, I can get a username, and then ultimately the password and tokens would be those two-factor authentication mechanisms.
So this is what the data looks like on the collection. So you're entering into this thing. It looks to you, the user, like a normal authentication. But in the back end, this is literally storing it into a database where we now have copies of all of your data.
Yeah. But otherwise, to you, the user, this actually looks like a legit site. So these are set up custom, and depending upon how you within your organization might use the portal. So it's not standard that you would use an Office 365 type of a view for login.
So this right here, what we were just looking at was you actually simulating a false environment.
Yeah, I was simulating that is a harvesting site.
I gotcha.
The purpose of that is it's going to pull down the web, the typical, your standard Microsoft's O365 login site. It's going to say, okay, proxy the connection between the user and their server through me, and then that's how you're able to intercept the credentials. That, as well as another open source tool used by many people out there in the security community called EvilGenix. And so there's many cool features that you can leverage and use for that. And ways you can integrate with it to create your own custom fishlets, which we have had to do on prior engagements. But yeah.
So just to, if I'm understanding, so you go back to that screen, that fake screen with, I think, Rio de Janeiro in the background, right? So you've got that. That's where they would enter in the information.
Mm-hmm.
Then it captures that and it puts it into that format down here below where it says test test.
Yep.
So it's filling in the username and password, and it just keeps doing that automatically, it sounds like. So then that's how you build up your database of username and password. Am I understanding you correct?
Well, this is how you would build up your database of users who have clicked on a phishing email. So if we sent this email and we said follow this link, and the user was to follow this link to log in to update their account credentials, this would be the site we're sending them to harvest. And so through us harvesting, that is where within that prior database I was showing you, we would see their usernames and passwords. To obtain a user's email addresses, it goes back to these harvesting scripts. Again, we just leveraged one. There are multiple out there that can be used in collaboration with each other, which might be something that we do to, again, get more email addresses. But for the sake of this phone call, we've only just demonstrated one.
And this, by the way, this entirety, everything that you see here was put together in just a few hours. So you can see that the tools used against you in corporate America are highly resourced, highly developed, very effective. And for the attacker, it is very minimal effort to affect a specific attack on your company.
Okay. Any questions from anyone on this call?
One quick question. Oh, go ahead, Andrew.
Sorry. So the website that you're collecting the information from is a legitimate Microsoft website, and you're just using a proxy, so you don't even have to emulate the Microsoft login page.
Correct.
Okay.
Yeah, in the middle.
And would you mind elaborating a little bit, like if I enabled 2FA or multi-factor authentication where I'm pushing SMS text to my phone or receiving a voicemail, how would you be able to bypass that?
So with the method of this tool right now, I don't believe they support SMS-based authentication. It's primarily through tokens. So if you're using an authenticator-based application and you receive a random 6-digit code, so after this sign-in page, you would be presented with enter your 6-digit authentication code. You enter your 6-digit authentication code or the code that was pushed to your mobile phone. We would be able to capture that token that is being used to authenticate the client to the server and say, okay, now that we've captured that token, let's reuse it again. Because in multi-factor authentication or 2FA, most times the token can be used more than once, and especially in a circumstance where I'm proxying the connection and you're not directly authenticating to Microsoft's resource, you're just going through my server, your authentication didn't go through. So that token is still usable.
Interesting.
So like my site, on this site, right, I can select a URL to send you to. So after you, if I can go back here. But I can select a URL to send you to after you have successfully input your credentials into my proxy. So after you've successfully input your credentials into my proxy, I could just send you to a YouTube video. That's effectively a Rick Astley, and I could Rick what you write. Or I could send you to a legitimate error page and say, hey, your authentication didn't work, and you as the user might say, oh, something happened, my auth didn't work, and then you might retry it again, or you may go somewhere else to use it. In most cases, some people might, let's just say for sake of argument, they may redirect you to a legitimate resource. So you just completely forget and say, oh, it must have errored, I got redirected to another site. And even if you've already determined, okay, after I've input my credentials incorrectly, I'm on a legitimate site now, you may not think back to the fact that someone has already captured your creds.
Yeah, and so you're in the middle, but there are many different ways that you could engineer this to get any user of any sophistication to comply. So, for example, you might redirect them to the password recovery page, and then it might say, "Oh, you failed your login too many times. You're going to have to recover your account now." And everyone's like, "Oh gosh, that's terrible. I should do something." Again, there are many different ways to overcome whatever obstacles have been put out there, but it all starts with using things like homeographic domains and other little pet tricks to dupe your human beings using computers to making a simple and a mistake that almost anybody would make readily.
So, do we want to take just a couple of minutes to talk about any of the solutions or things that would guard against this? I know we're almost to the hour, but maybe just take a couple of minutes on that.
So my recommendation, and I'm always a little pessimistic, is going to be frequent, maybe quarterly security awareness training that is directly pinpointed to users that you are even seeing fall victim to security awareness training you have in place. So most security awareness training that is in place don't necessarily go to the measures that we have gone to within a real world phishing attack to do certain types of exercises like this. They may afterwards send you to a training module and tell you, hey, here's this, but then you as the admin will see someone's just click through it. If you continually are training your employees on how to recognize the additional items outside of just the lock and the HTTPS and outside of just, oh, the email came in and it has the standard company signature. Okay, this might be legitimate. There are different switches that have to be used and implemented, or even trained employees on to be able to recognize. You have certain solutions from Barracuda which can recognize spam-based domains, but depending upon your threat actors and whether they're setting up a new resource or a new site, there might not be those flips or those triggers to say, okay, this is phishing, or this is
Okay,
an email
but
we need to
let,
move
let's
away
do
from
this.
employee view.
You can measure how susceptible you are. You can do an engagement where we do social engineering attack that simply subjects your users to a friendly, non-destructive cyber attack. You can then use that to say, okay, here are the folks that fell victim to that. If you couple the training with assessment or measurement, that's going to help you work with your team to get them to a higher level of competency. And then in addition to that, there are technologies that you can implement which will, again, mitigate some of that risk. But the very best thing you can do is one, training, two, measure and assess, which you can use ProServe for that, and then three, then based on the knowledge or data you gain from that, have someone assist you, like our SPCs, with which technologies you should put in place to cover the specific problems your organization has.
Is there
All
any
right.
technology? Do we have time for one more question?
Yeah, go ahead real quick, Andrew.
Is there any technology that would either identify that you've been proxied to a legitimate website? So in other words, is there anything available on the market right now that would send some sort of dialogue or message that says you're being routed through a proxy, or you're attempting to hit Microsoft.com, but you're not on a legitimate website?
That's an arms race kind of deal. So there are solutions out there that to varying degrees of success accomplish that. The problem is it is constantly evolving, and as soon as a particular technology is evolved, the bad guys, they spend a lot of time, energy, and money to figure out how to get around those things. So they're just like everything security, there's no one bullet. It really is a highly adaptive, intelligent, decision-driven methodology to success.
Thank you.
All right, thanks everybody. And I just encourage everyone to send emails or ideas of other future calls that we could have. And thanks, Brett and Josh, for your time and putting this together. And we'll have some follow-on calls, probably touching on this topic as well. So thanks everybody, appreciate it.